All right, welcome back to the AI Research Roundup. I am your host, Alex. Today, we're looking at a fascinating paper from the Papers with Code trending list called Let Them Talk, Audio-Driven Multi-Person Conversational Video Generation. So, we've all seen those AI talking head videos, right? They work pretty well for one person. But this paper highlights a big problem. When you have multiple people and multiple audio streams, current models struggle to match the right voice to the right person. To fix this, the researchers propose a new framework called MultiTalk, which is designed to generate entire conversational videos. And the great news for anyone who wants to experiment with this is that the authors have released all the code for this work. Over on their GitHub page, you can find the complete implementation for the MultiTalk framework. This includes things like the inference scripts, which are basically the instructions you'd use to run the trained model on your own audio and video clips. They also provide the pre-trained model weights. The pre-trained model weights are essentially the learned knowledge of the model, saving you the massive cost and time of training it from scratch. So, to see what this MultiTalk framework can actually do, let's look at Figure 1. It shows some really compelling results. In the top example, we see a man and a woman talking. The model is given their conversational audio and a simple text prompt that says they were talking, and then they kissed. And as you can see in the generated video frames, that's exactly what happens. The lip movements match the audio, and the action follows the text. The bottom example shows it's not just about lip syncing. It also understands and creates broader actions, following complex instructions from the prompt. Okay, so those results are impressive, but how does the model actually pull it off? Figure 2 here gives us the full pipeline for the MultiTalk framework. It takes three things as input: a reference image, a text prompt, and the separate audio streams for each person. The model's core is a diffusion transformer, which generates the video, but the secret sauce is how it connects the right audio to the right person. For this, the researchers introduce a new technique called Label Rotary Position Embedding, or LROPE. This method cleverly assigns numerical labels to different regions of the video frame, like person 1 and person 2, and also to each audio stream. By making the labels for an audio stream and its person numerically close, it ensures the model always knows who is speaking. And that label rotary position embedding technique really pays off when you look at these qualitative comparisons in Figure 6. Here, we see MultiTalk pitted against other models like Halo 3 and Sonic. On the left, the prompt is, "A man closed the laptop." Most competing models just generate talking motions and completely miss the action. In contrast, the video from MultiTalk shows the man actually closing the laptop. Similarly, on the right, with the prompt "A woman takes up the headphones," only MultiTalk successfully generates the specified action, showing its superior instruction following ability. And that ability to handle complex scenes extends to longer videos too. Figure 10 here shows this off. We see two women having a conversation over a longer period. The model generates this by using an autoregressive method. Basically, it generates a short segment of video, then uses the last few frames of that segment as a starting point to generate the next one, and so on. This approach creates a seamless, continuous video where the characters' appearances in the background stay consistent, and their interactions look natural throughout the entire clip. From generating complex actions to creating long, seamless conversations, it's clear the MultiTalk model is a significant step forward. The key takeaway here is really how the label rotary position embedding technique enables precise control over who is speaking and what they're doing. This work pushes us beyond simple talking heads and towards generating truly dynamic, multi-person scenes. That's all the time we have for this episode. Thanks for tuning in to the AI Research Roundup, and I'll see you next time. I'm Alex.